Okay, good.
It looks good.
Cool. All right. Now, now that we're back from the break, I will go ahead and get started with compiler toolchains. Hopefully by the end of this section, you'll have a basic understanding of what compiler toolchains are, why we use them, and you'll be able to find out which compiler toolchains are installed, which ones you need, and be able to load which ones you want. So at most of the universities at most HPC centers in Sweden and many around Europe, software is built using the Easy Build deployment framework. And under this framework, software is built around what are called toolchains. These are mutually compatible groups of C and Fortran compilers, MPI libraries, linear algebra libraries, and other really fundamental programs that are used internally by the packages that you might be more familiar with, like Python, R, GROMACS, and so on. So if you can think of these familiar software packages like cars, then the toolchains could be thought of like car platforms. So you might have a lot of similarly sized cars from several different brands, say like Honda, Toyota, Mazda, might all use the same standardized engine components and power steering systems and wheel axles, all from the same manufacturer. So that's kind of the role that the tool chain is performing under the hood of the more familiar user-facing packages that you interact with directly. At most HPC centers, if you're going to build and compile software for yourself or for distribution, regardless of whether you use Easy Build, it's advised to use toolchains just to keep the software versions consistent and reproducible. Anyway, so let's briefly talk about available toolchains by HPC Center. I'm not going to go through all of these lists in detail. I just want you to note a few overall features. So at most of these facilities, there are sort of two main groups of compiler toolchains. There's the open source versions that are associated with GCC, the GCC compiler, and then there are the Intel compiler toolchains. So all of these different toolchain options will have the compiler in them. Most of them will have, a lot of them will have an MPI library, and then you might choose other options if you need specific math libraries. But if you can only remember two from this list, I would remember FOSS and Intel. 9 times out of 10, those are the only two you need. So the setups are very similar on HPC2N, at LUNARC, and at UPMAC's Pele. At Tetralith, you have similar but maybe slightly fewer options, but unusually these will depend on this build tool -easy build module. So Tetralith is a little bit unusual in that it requires a prerequisite even for the tool chains. The only other one that's like that is Dardel. And Dardel is just an entirely different beast. They use the Cray programming environment. I'm not going to go into details about this. If you want to read it, you're welcome to do that. And I've included some links to the PDC documentation on these tool chains. Also at UPMAC's, you have some older machines, Rackham and Bianca, In these cases, the tool chains are a bit less visible because most of the software was built without Easy Build. At these facilities, you would expect to load the compilers, NPI libraries, math libraries, and other modules individually. But you can still refer to the common Easy Build chains as sort of a template. And these have been, the ones that are included down here are mainly intended as to be demonstrative, but there are some tools some packages on Rackham and Bianca that may use these tool chains. So if you use ML avail, and then the name of this tool chain, you can see if it's available. And if you use ML spider on a particular package and see, and if you're really lucky and you do ML spider on a particular package, you might see one of these listed as a prerequisite. But most of the time, what you will see are, for prerequisites, you will see GCC or Intel compilers specifically, and OpenBLAS or Scalapac and other math libraries listed separately, and MPI. And UpMax also has some documentation about the combinations of compilers and NPI libraries to use. So these are listed like so. But anyway, I am going to focus on the facilities with a common setup and Tetralith going forward. There are also CUDA-based tool chains at some facilities with GPU nodes. It's set up again very similar at Kebnekaise or on Kebnekaise and Cosmos. Oftentimes, it's just as well to import, say, FOSS and then the FOSS tool chain and then load CUDA separately. That usually also works. And at UpMax Pele, that's what you will have to do, is you'll have to load the FOSS tool chain. You'll have to load the FOSS tool chain separately, and then load CUDA if you're going to be working on a GPU. At Tetralith, there is just this one that loads GCC, CUDA, OpenMPI, and all of the others. So it's like a FOSS toolchain, but with CUDA built in. It's basically the same as FOSS CUDA at other facilities. And if I scroll over here to Rackham, be aware that if you are on Rackham, the GPUs are only on the login nodes. And so they should not be used intensively. If you want to use GPU nodes intensively, you need an account on Snowy. So I know this is all pretty overwhelming, but especially if you're a new user. But like I said before, if you can only remember a couple, FOSS and Intel are usually pretty good, all-purpose tool chains to remember. FOSS again for the open source and GCC based open source software with GCC compilers, and Intel for software compiled with Intel. And then if you're really unlucky, you might have to you might end up with open source software that uses Intel's math kernel library. In that case, you might have to use something like GoMKL. But then there's probably going to be some additional complications that we will not go into today. So let's do a quick example. So you can see over here, I'm logged into Tetralith. If I, to the modules that are loaded right now are just this HPC.1 and some other version, some other stuff. I'm going to do ML avail FOSS. It's not available yet. Again, because I have not loaded the build tool dash easy build. So let's look at what versions of those are available, just the two. So I am going to do ML Control-Shift-C, Control-Shift-V. That's how you pick up the versions with all the version numbers very quickly. So now that's loaded, and now I can scroll back up to that ML avail FOSS. This will be a little bit, yeah, okay. And now you can see two versions are now available. And if I type ML FOSS 2023B, by the way, this D in parentheses here, this means that is the default version that will load if I type just this part and don't include the version number, or in this case, the year. So if I load that, then I type ML, you can see it loaded a whole bunch of stuff. So FOSS includes GCC core, GCC, also some of these hidden modules, zlib and utils, things like that. You don't really have to, most users don't have to worry about those. OpenSSL, that's for security reasons. Then there's the OpenMPI for the MPI library, OpenBLAST, FlexiBLAST, FFTW, FFTW, MPI, and ScalaPack. Those are all for these are all the math libraries that are needed to do linear algebra and equation solving. And of course, it lists the module that includes all of this at the very end. Now, just to give another example on Cosmos, if I do ML spider FOSS, get quite a few more available modules, and these would all be loadable directly because the on Cosmos you do not have to load preload any prerequisites for toolchains. So I'm just going to select that, the ML FOSS 2024A. And now if I look at what all is loaded, it's more or less the same it's the same list that's up here, more or less. Just there's a couple of extra modules in here somewhere. I believe this UCC is different, and this PRRRT is different. And I'm not sure what those do, but users typically don't have to worry about those. Anyway. So we've already gone through these, and I've shown you what these loaded. All right. So after loading a tool chain, as you can see, many new modules become available. So whereas before, if I do ML avail Python on Cosmos, that shows every module that containing Python in the name that is available to load. Whereas if I do ML purge so that nothing is loaded and I do the same thing, it doesn't find anything. So ML avail is to see what modules you can load given the tool chain that you've already loaded. And you saw that earlier in Brigitta's lecture. For some packages with very long or very short intervals, there may be multiple versions of a software package available for your chosen toolchain. R is notorious for this. As I mentioned before, the version number, if you don't give a version number, the version that will load is whichever one has the D next to it. This default version is subject to change, so it's recommended that you always provide a version number if you care about reproducibility. And keep in mind that that doesn't just apply for software releases. I have been in situations where a Python package actually broke because of an update. So anyway. Also to keep in mind, not all modules have a version associated with your choice of toolchain. So you might have to switch. If you do switch toolchains, keep the following in mind. In most facilities, the module system will attempt to change anything else that you have loaded to match the new choice of toolchain, so that it will attempt to upgrade or downgrade any previously loaded modules to match the new choice. However, if one or more of the modules loaded with the previous toolchain do not have a version installed that is compatible with your new toolchain, then the module system will raise an error and the modules will fail to load. Also, I'm going to skip that version. I will say the reason that you should avoid the system versions built into the operating system are not just because they are old, but because they are subject to change. So most of the time they're old, but occasionally they will get updated. And then you can find yourself in a situation where the, Python jumps 4 versions and suddenly the NumPy version changes and it no longer has a matrix class. That is an actual thing that has happened. All right, so if you're compiling serial code with toolchains, your compiler choice will depend on your coding language and whether you're using an open source toolchain or an Intel toolchain. So I've set up this little matrix to show you which which compilers go with which coding language and which toolchain. So if you're coding in, say, C++, and you're using a GCC-based toolchain, then the compiler that you want to use is G++. If you're coding in Fortran and you have an Intel toolchain, if the Intel toolchain predates 2023, you probably want to use iFort. iFort will still work for newer versions, but there are also these IFX and other Intel toolchains ending with X for years 2023 onward that use this one API, if that's available at your facility. I know Cosmos has had issues with that, getting newer versions. It's kind of a similar story with MPI. If you compile software with MPI, there will be an MPI compiler that is appropriate for each coding language and each choice of toolchain. If you're using OpenMPI and say your coding language is plain C, then your MPI compiler will need to be MPI CC. And if it's Intel, it would be MPI CC. One convenient thing is that most of these are it's convenient but also confusing in that the Intel MPI compilers are almost identical to the open source ones, except that they contain an extra I. And the exception to that is the C++ one. If you're inside a JavaScript, also keep in mind the executables that are built with OpenMPI need to be run with MPI run, but for Intel-based MPI scripts, instead of MPI run, you would use srun. And this is a sample template using OpenMPI adapted from LUNARC documentation. So you would need to adjust some of these parameters based on what is what are the options available at your facility. Most of these will be the same. But you will have the number of nodes that you'll be able to book, and the number of tasks that you'll be able to fit on a given node will vary. And again, you'll have to change which tool chains are available to load, which whether or not they have prerequisites, or and then you have the main executable down here. So if I were to adapt this script to Tetralith, instead of just module load FOSS 2023A, what I might do is, so this one only has 2022A and 2023B. And I already showed you that I needed to load this build tool dash easy build. So I would have to do module load, this build tool dash easy build, and then FOSS 2023B, for instance. And I could do all of that on one line. So let's see, do I have anything? Oops. So let's just do that really quick. I'll purge. Build tool, easy build, 4.9. Okay, and then FOSS 2023B. I'll show you that that loads all on one line. That. There we go. We've got all our modules back. All right. We're running a bit late, so let me